I noted earlier that the outside of the meander is where we're going to expect to have the fastest velocities. I also showed that in the cross-section view as well. Same idea here. The red line is showing where we would expect on this particular meandering stream the fastest velocity to be. And you can see as we go to the outside of the meander, where the deepest channel is, it's going to become on the outside. And so we're going to get on this particular outside of the meander something called a cut bank. And so you're going to get erosion occurring here as the sides of it are removed and this channel becomes steeper and steeper and steeper, creating on one side a very steep side. And this continues, of course, on the outside of this meander as well. However, on the inside, we get the slower moving sediments, moving very slow. And so what ends up having is moving so slow that it actually starts accumulating. So we get a deposition occurring on the inside of the meander. And so that's our point bar deposit. And so this is a particular pattern that we in Indiana in our meandering streams. And I'm going to use an example here of a river in which we then have a flood event. So guess what? We just identified the floodplain as well. And eventually what we have is maybe this stream is coming at such velocity, such a heavy rain event that it actually cuts off a former part of its meander. And eventually what happens is sediment builds up, separating that particular meander from the previous part of the main branch or the main part of this particular stream. This is eventually over time is going to separate as that flood goes back and subsides, and so we end up having an oxbow lake being formed here. So this is an oxbow lake that's essentially been formed as a cutoff of a previous meander of a stream. Eventually, that oxbow lake will dry up as it no longer has a source for its water, and so it becomes a meander scar.